Hello, everyone. Thanks for joining this presentation on multimodal RAG. So we are experimenting with an agent versity bot. It should able to, it might ping you personally. So if you if you have any questions, it can personalize the answers based on your background. So feel free to share your, maybe you're software developer or if you're coming from any other background, please do share your background for it to customize the answers. Um, I see a lot of new names. I don't know if you have been to any of our previous presentations. We do presentations every other week, and all of the previous sessions have been recorded and they are on our YouTube channel, so you can always check out those sessions. And please do use Agent Versity Bot. That would help us to streamline the development of AI agents for upskilling anyone. We're also building AI agents to basically help anyone navigate through lab environments as well. So thanks a lot. We can get started in next 2 to 3 minutes. Just to hoping to see um, more members to join this call, and then we can get started with this. And feel free to share your what you do and what are your uh, uh, what is your background. I will launch a poll. Feel free to just put in your answers so that we can gauge your background. Most of our previous events were attended by almost 80%, 70 to 80% software engineers, and rest of them are not software engineers, like mainly either coming from mixed product engineering background or some are from data science and ML engineering background. So that's good to know. And today's meeting, I know it's virtual, but feel free to share your LinkedIn profile if you want to network with anyone else. And during the presentation, if anyone has any questions, please do drop those questions in the chat box that we can answer. And also make use of the Agent Versity bot if you want to get any kind of customized answers. And we're also live on YouTube and other platforms. And if anyone of you have worked already on RAG or multimodal RAG, please drop in the chat. Um, Let us know what you've been working on, and if you could answer any of the questions in the chat, please feel free to answer those questions. So it's more these community meetings are meant to be sharing knowledge and to promote synergy. So please do feel free to do that. Um, yeah. So let's get started. I think we have quite a few. Uh, Let me share my screen. So yeah, yeah. So welcome everyone again to this presentation on multimodal RAG. Last week we have gone through vision language models and also VLLM. And this week we're going through multimodal RAG. If you have already attended the session on VLM, maybe we have covered few concepts there around, fusion and some of the concepts which might be a bit similar to multimodal RAG. So today I'll go through a few slides and then I'll share you a GitHub project. You could go ahead, clone the project, and then start implementing this project locally. So if you have OLAMA that you want to use for your local models, you could do so. If you need any help installing OLAMA, please do let us know. These slides would probably take us around for maybe 30 to 40 minutes, for 40 to 45 minutes, and then we will go through that hands-on session on if you don't have OLAMA, you could install it straightforward. It all depends on your machine, how big is your machine. Based on that, there are quite a few models which are available that you can go through. Hopefully you can hear me. Still okay. Let me, I had to put my Bluetooth on. I have 2 years old. She's okay. I don't know if my earphones are still charged. They're not charged. Sorry. So yeah. Let's do this. Good. Um, so yeah. So let's go ahead with this presentation. Uh, and after 40 minutes, we'll go through the presentation, mainly the hands-on session on how you can implement the multimodal RAG locally. So let's start off with like, why do we need RAG, right? Some of the problems. So basically RAG means retrieval augmented generation. If you are completely new to RAG, um, you it's you should basically understand how LLMs are trained. These large language models, you know, models which are powering ChatGPT, are models which are currently used to uh, answer any of your questions. It could be Grok, models powering Grok or Anthropic Cloud. All of these large language models are trained to certain time in uh, are only trained to a certain time. So they're not continuously trained. These models are only trained up to a certain point. So they have a knowledge cutoff problem. So if a model is being trained maybe till last year, April, most of the models have been trained only till April. It all depends on the vendor. But if you ask the model who is the president, it would probably answer, maybe Joe Biden, not Donald Trump, because it was only trained till a certain point. So unless it has access to the latest information, it would only answer facts and all the news which only happened at that point of time. So that is a problem with LLMs. Even though ChatGPT would not um, give you a wrong answer now because it got access to internet, so it gets the latest articles from the internet. It understands who's the current president, and then it gives you an answer. That's all happening through internet, access to internet. So these LLMs, even though they are trained to a certain point in time, with the access of external tools or with access of external data sources, it can answer latest information. And most of them have the problem of hallucinations. They might mess up facts, they might mess up your years in history. They are not certain. They might invent like new facts which we are not aware of. So these are some basic issues that all of these LLMs possess. Knowledge cutoff and hallucinations being one of the huge problems that they have. So how RAG really helps us with it? So retrieval augmented generation. So retrieval, it means retrieving something. augmented means you're augmenting that data that you retrieved, and now you're generating. What's generating? The LLM is generating. So that's the strategy that we're using. That's what RAG actually means. So you're retrieving the facts, you're augmenting the facts with the user question that they're asking, maybe who's the current US president. Now the LLM would go out and get the facts from Wikipedia or other sources, and now it's able to generate the answer based on the facts that it retrieved. So that's what RAG is. So without RAG, your LLMs are just only have knowledge up to a certain point, and they could even hallucinate because they cannot provide you with citations, which is pretty common now. When you go into Perplexity or even ChatGPT or any of these tools, which you might be using on a day-to-day basis, you would get a citation saying that this is where it got the information from, because what's going on under the hood is a RAG process. Since these models are not continuously trained, because continuously training these models is really expensive. So what are the components behind RAG? So there should be a document store, um, basically a vector database. I will go through what is a vector database from in the coming slides. But before that, just understand how an LLM processes a question. Any question that you ask an LLM or a large language model, that question is not directly sent to a model as it is. The processing within a large language model happens through numbers. Basically, what's going on under the hood is the matrix multiplication. There's a huge attention mechanism, which I don't want to go through this attention in this session now, because that itself would be it would probably take a lot of time, but I have covered that in the previous session, VLLM, where we have actually hosted a model ourselves and explored how it works out. And I did cover a significant amount of time in covering VLLM. And also there are some videos that I can share you from three brown, one blue, I guess the channel. They do explain a lot about attention mechanism and how it works. So any text that you're asking, any question that you're asking, it has to be converted into numbers. So that's what that's done by different encoders. And these encoders convert text into numbers, and they call it, tokens. First thing is every word is converted into tokens, and then the embedding model or the encoders convert them into embeddings and store them in a vector DB. So that's what a document store is. And the document store also stores all of the information that the LLM might not already be trained on. Maybe it could be your enterprise documentation. It could be some data policy documentation that are internal to your enterprise. Those are not behind a firewall. So these LLMs are not obviously trained on them, but you want to use LLM's cognition on those documents to find reasoning, to answer questions on those documents, to find any kind of summary, if you want to do summarization. So your document store would store that. And most of the document stores are vector databases that store these embedded documents. Embedded are nothing but which have been processed to store as numbers, and they are named as vectors. And there is also something called a retriever. So a retriever searches for the document store, and it retrieves the top k relevant chunks. So if your document has policies for, it could be your policies for your data policies. It could also be any of your internal PDFs for maybe like 1,000-page PDF. When you're asking a question, what it is doing is to compare that with your existing data store. So it's basically doing a search of your existing documentation. And since it is a huge documentation, what it does is basically compare and see if these numbers are similar to the existing numbers or existing data within your vector store. So those are basically stored in this way. So within the vector database, if animals and vehicles, those are all clustered in certain way. So those are all stored in a high dimensional vector space. So the retrieval happens in this layer. So when a question is asked, maybe, my new puppy, you know that
puppy refers to animals, and this is how all of these vectors or these numbers are stored in a high dimensional vector space locally. So when you're asking for a question, you're basically looking for something similar. My new puppy would probably point to something, um, something related to the animals. And you might already experienced it if you're using iPhone. So if you go into your iPhone and search for maybe, you know, your pet pictures, or maybe look for something in, maybe if you have ever visited any kind of um, uh, uh, any tourist place, even though you don't know when that picture was taken, but you can just search naturally, your pictures pop up. So what's going on there is a similarity, such similar way. There's a vector DB in your phone that's actually doing the same thing, which is basically retrieving the data from thousands of pictures. You don't have to manually do it, but rather type it. It will retrieve all of those, and that's basically happening through this processing, where all of the vector DB stores different entities and captures this meaning in the multi-dimensional, high-dimensional vector space. So vehicles are far away from animals, so that's the reason why you see vehicles and few things are clustered at a certain point. And these what the embeddings are. These embeddings are all of these embeddings are actually stored as different vectors. It could be a picture, or it could also be text. We will go learn why we are going with multimodal. What does multimodal mean? But just want to explain you how does this work under the hood and inside a vector database. There's also indexing to basically retrieve your vectors really fast, and also there's a search, finds nearest vectors instantly. So these are all things which a vector database uh, architecture has. So we know these are some basic components. There's a retriever, there's a re-ranker, and there's a generator. Generator is nothing but your LLM that generates it. And re-ranker is whatever we retrieved. A re-ranker basically optimizes that retrieved part. Maybe out of 1,000 chunks, it is retrieving maybe 10 or 20 chunks of text, which might be similar, but that might not be the right content that it retrieved. So you can have a re-ranker that just goes in there and reorders the results so that the accuracy improves. So we'll go through that eventually through the slide, like what exactly re-ranker is and do we need, and how do we need, and where do we need. So yeah, there's a retrieval. It's search for external knowledge base. There is augmentation, which is combining the user query. User query is any query or any question that you are asking any product like ChatGPT or Perplexity. That is your user query. So you have the user query with retrieved context. The retrieved context is from external DB. If in case you're asking for some facts, maybe some about any game that happened yesterday, usually this retrieval happens through the internet. And then the LLM synthesize the answer through the generation process, because now it has the user question and also it has the external knowledge about probably yesterday's game, and LLM now makes a decision. So you're basically using LLM's decision-making skills or reasoning skills to answer what it is, but you're also providing the data, which is the ground truth from which it has to make the generation from, or from which it has to answer your question. So it delivers the grounded and factual answer. What is grounded? So it's basically something that is backed by facts. If in case you just go and ask an LLM to do that, it could generate it, but it might be a wrong answer. It can go ahead and retrieve maybe a year when, when World War happened. It might retrieve that date, but it might not be the right answer because it's coming from the LLM's knowledge. So when something is coming from LLM's baked knowledge, which is knowledge that it gained through the training process, this knowledge is actually a lossy compression. So it might not be right all the time. So these answers might not, it could be made up or it could be hallucinated because it might have memorized some different date and it might give you a confident answer. But if the retrieval happens where the model could go into Wikipedia, get the right answer, and now generates it, now you're not relying too much on LLM's baked up knowledge. Rather, you're just referring to the external knowledge, external grounded information, which is backed by facts, and now you're generating the response. So that's where RAG really shines. And if you're working in enterprise, you would probably be doing this. You're not just calling an LLM and asking it to produce an answer. You could do that, but end of the day, you will not get the right answers. You always, if you want to audit whatever answer that LLM is providing, it always should be backed by some facts, even though LLM is already trained by that knowledge even beforehand, right? Maybe you're asking about some vaccine data or whatnot. So that's the reason why RAG really plays a huge role. And everyone is offering RAG as a service. I mean, you could go into Copilot. They say, okay, you upload your PDF and we can just get you you can chat with your PDFs, summarization, all of these AI bots, which say, you can chat with them, maybe chat with your meeting summaries. Everything is RAG under the hood. So as we know, this is something that happened before with the knowledge cutoff, hallucination, and after RAG is this. So I just want to show you that. And we've already gone through this. There's a retrieval process, generation, and the response. So the vector DB is something that you probably need to pay a bit of attention on, because the vector DB could have different algorithms that it is using under the hood, which you need to be at least a bit aware of. So what are the different algorithms that are available is there's some graph-based algorithms, which is hierarchical navigable small world. So it's basically creating graph for the data that you have created embeddings for. So it's creating a multi-layer neighbor graph. That way it's very fast. It does have a fast recall search. So it's able to search with facts since it is a graph. You know how different entities are all related. So you would get a proper answer with good recall. What is a recall? We'll go through that in the next slides. Clustering based, it's IVF. Everyone is, I mean, you might have already been aware of this as traditional search algorithm. Cluster vectors is, basically searches in few centroids and all. So that's how most of our search technologies work. Compression based is product quantization. Basically, you're creating sub-vector quantization. It's really low memory, maybe something that is working on your phone. Hybrid is kind of having best of the both worlds, combined speed and compression. And today we are using HNSW in our demo. So what are the limitations of text-only RAG, right? See, ideally, most of the data out, it could be your PDF files, it could be any of the any of the data in the external world, which is unstructured data, which would not just be purely text. It could have tables in it. It could have images, and it could also have videos. They could also be, some of the unstructured data could also include audio. So most of the data out is not just pure text. So how do we use RAG in those scenarios, right? Because if you have your PDF file and just want to chat with your PDF file, it might not answer your questions if you're only trying to create embeddings for your text itself. Because there could be a table that's capturing a different kind of information. And when you want to interpret that, it's very difficult. There could be a diagram that is showcasing a concept, and it will be really difficult for you to really grab that information. There could be product images, UI screenshots, there could be videos which carrying different context. There could also be voice recordings. So today we are only limiting to images and also a PDF with different, maybe a product demo or a product catalog thing. But we might, and also anything to do with images, but there is also video. Video is a bunch of images, so you could also create a RAG for that, but that involves a lot of pre-processing, because you might chunk video to different frames, and then you need to store that, and then do your RAG on that. Maybe we'll have a different session for that, because that itself has a lot of bottlenecks, I can say. So now we know, like, why do we need multimodal RAG? It's because the world out there is not just pure text. We also have images and other data that does have that projects and talks about the context. So you should. That's the reason why we have multimodal RAG. So in multimodal RAG, you basically process text, images, audio, and there are different ways in which you can process that. You create encoders like BERT, CLIP, and Whisper. So CLIP is, we covered that in the VLM session last week. So CLIP is something from OpenAI. It was out in 2022, where it basically learns the text and image. So when it learns cat, word cat, it also learns how it relates to cat features in an image. So that way, it's able to learn by going through a lot of images and videos. It's able to create those embeddings for all of the multimodal information. And Whisper is purely audio. Basically, it's converting audio to text. So cross-modal retrieval is store different vectors. Previously, we know those vectors were only pure text, but now these vectors are for text and image and retrieve across modality. So you're basically retrieving uh, you're basically retrieving cat. When you're just typing cat, you're also getting cat images that are retrieved. You're retrieving an animal, you also get you're retrieving anything related to animals. So the image is retrieved. I mean, that's where you have cross modality. You're just typing text, but still your your uh, your vector space also has the image embeddings, which are closely aligned with the text embeddings. So that's one of the reasons. That's one of the reason why you are able to retrieve that when you're asking a question. Because previously, when you're asking a question, everything is happening in the text space, but since there are images involved now, so you get this. You're able to retrieve more information, not just the text, but also images, since you're doing this cross-modal retrieval. Modal just implies modality. Fusion and reasoning. So how you are able to do that reasoning, or how you're able to fuse things together, is basically through cross attention. So we already covered this cross attention in a previous session, but cross attention is something that projects images in the text space, and by creating different layers within an LLM that already learned language, but how it can connect itself to the image world. So that's how cross attention actually creates attention between not just images, but not just between text words within text, but also words and also the images related to that word. So these are some basic features in multimodal RAG, and just like a regular RAG, it also has different steps. Query could be a text and image, or even audio. So when you see a multimodal RAG, you're not just purely sending a text, but also you're also attaching an image. And that's the reason why you could able to ask a question around any image. So now if you open your ChatGPT app and upload an image and ask it questions on that, so the thing that happens is, after you upload the image or even text, maybe you upload an image saying that, can you describe this? So now you have two inputs, which is an image and also text that is asking, that way you're asking to describe that image. These specialized encoders, the encoders that we previously discussed about, BERT, CLIP, or Whisper, depending on which modality that you are working on, you have these specialized encoders which will encode this data and store them into multi-vector DB. So and multimodal vector DB, and from there you have a cross-modal retrieval that happens, where when you're asking questions on, can you explain this? The multi-vector DB retrieves some additional context, which is the image, that because even to retrieve any kind of similar images that which are already there, maybe you're asking about you have a huge database of maybe a dental data, or even like skin information, or it could also be a product catalog where you're asking questions about a specific product. You basically retrieve that additional context from here, and then you do this cross-modal retrieval, because since the multimodal vector DB stores not just the text but also text and images in the same higher dimensional vector space. After the cross-modal retrieval happens, now comes the fusion and re-ranking, which is an optimization layer. You may not always need it, but once you know your performance is bad, you probably introduce this re-ranking, and then comes the answer generation. So uh, it's almost similar to the same text-based RAG, but there's only few. You talk about the multimodal vector DB rather than the regular vector DB, and now you have a cross-modal retrieval that happens here. It just all happening through specialized encoders, which we know are already available outside, and we'll be using those encoders. So yeah, I mean, in a high level, and maybe through a diagram, you can see these. You have photos, chat, different scan documents. Those are all embeddings are created for this. And those are all stored in the vector database, which has the unified embeddings with all of these data. And vector DB stores everything. And from here, you have the multimodal RAG process. So you can ask any user question, and multimodal LLM retrieves, all of the, uh, you know, all of the information from here, and then it basically the reason why there are different arrows this way is once the user query augments with additional information from here, from your vector DB, and then the LLM generates it, and the output of the LLM would again end up in a different vector DB because now you ask a follow-up questions. So you in order to retrieve that follow-up question, you need to have that data somewhere, right? So that data again have to be processed and stored in a vector DB. So that's how it's more of a loop that goes on, but it's more grounded now because now it knows what image it referred and how it is able to answer these questions based on this. So yeah, and there are different. I mean, these are all different parts of it. What is the major what is the major reason why we have a retriever is to fetch relevant documents or even images from it. What's going on here is the nearest neighbor search, semantic search, uh, and it has high recall, but may also include some irrelevant documents. There's a re-ranker. Re-ranker is more of an optimizer that after you retrieve relevant documents, but there could be some irrelevant items too, so you need to remove them. So now a re-ranker could again be a VLM. A VLM is a vision language model. I think we had a huge session on that last week, and a cross encoder. So you use that to make the retrieval a bit more optimized before you're sending that to a generator. So now a re-ranker would just filter out some unnecessary data that is retrieved. And then you have a generation, which it could be an LLM or something that can produce the output. But how do you know what kind of performance metrics that you need to for the or it could be any RAG, multimodal RAG, or it could be any RAG. So you have recall. So recall is what percentage of queries at least have relevant item in it. So when you ask for a question, it's at least it's checking for if out of 10 results, if there are at least 5 results which are actually true or which are relevant, then the recall is probably 50%, right? It's only out of 10, it's only 5. So it's able to retrieve relevant information. That's what a recall means. And at K just means how many results you want to get from the output, right? When you ask a question in Google, you have 100,000 results, but we can't afford that probably in our vector DB. We only probably need from 5 to 10 or 20, depending on how much data we have, and how big is that data set and how complicated is that. So this K value is something that we could tweak to make the RAG more efficient. Sometimes if you do 10 or 20, means 20 results, you would probably have one result in there. But if your result is coming up in 19th position out of 20 results, man, your RAG is performing really poor because it's too much noise, right? So here you also have precision. Precision is how much fraction of retrieval items that are actually relevant. So it shows how precise your retrieval is, and it also shows the noise in retrieved in context. If there's any some information that is retrieved is not at all related. So that impacts your precision. Recall and precision. Any classification problem is a traditional metric that that you would probably use. MAP, which is mean average precision, is just to check average precision across all ranks. Usually if it is one, it's really good. If it is low, then probably the precision is compromised. So mean reciprocal rank is also one of the things. These are all um, different metrics that you can define and give you the accuracy of your RAG. How accurate is it to get the results? These results which we are talking about are something that is coming from your vector DB that could add to your question, and that has all the context that is needed. So even if you increase the K value a lot, probably you're burning out a lot of tokens, because if it's 20 or 30 results, you're actually sending all of those results to the LLM to make the judgment on the answer, or give a response to that answer. So yeah, we kind of covered all of the fundamentals of multimodal RAG. And before going through the next part of the hands-on session, like where we'll implement a simple multimodal RAG, I just want to maybe discuss any questions that you have.
Hi, this is Sri. I have a question
Yes,
on,
Sri.
when you store the embeddings in the vector database, right? And if I have a follow-up question, or like if I ask, I asked a question and then maybe someone else can ask the same question, right? So the question is related to the caching. So does vector DBs have the caching feature as well implemented, so that you get the next response very quick, not like it has to generally, right? If you ask a question, it has to go through the processing, right? So it takes few seconds. And if I'm asking the same question, does it take like same time, or like if it
Yeah.
has like caching implemented, it can go and get the answer quick, right? So do we have that feature for
Um,
the vector DBs?
Maybe it should exist. Usually
Okay.
caching, it might, because caching is way to optimize. And I know for the LLMs itself, there is something called a prefix caching, which will include the similar thing, what you're asking. Maybe someone is asking about, tell me a joke, and someone says, tell me a joke, and also tell me where I can eat tonight. So tell me a joke and tell me a joke are same part of the same question. So usually LLMs, when you are hosting this LLM using something like VLLM, they do provide this prefix caching to improve the output, and also there's prompt caching as well if you want to cache some prompt, system prompt, so that you save on the network layer. Within the embedding, within the vector DB as well, they could be a caching, but also up to the scale, right? Uh, End of the day, you're also creating vector embeddings for it, and also they could and you're basically doing this search, so you're searching for relevant things. So every and also within the vector DB, you're basically searching for something that is relevant to the question, and then you're carrying that into the LLM to basically you're enhancing the context here, right? You're basically making sure the context to the LLM does have enough context to answer your question. So
Okay.
it could, or it may not, but I'm not sure. We can ask agent bot to tell us that, but I know VLLM, which is the engine that hosts with paged attention amount, it hosts the LLMs that do have prefix caching. So if someone asking the same question, LLM already has attention for that. So the time to take that most of the time that we usually consume to answer your question is not around the embeddings, because search is really fast, but the most of the time takes in the inference. So inference is to process your question, which has to go through huge LLM model, which has thousands and thousands of layers with a lot of attention heads, that takes most time. That is where the bottlenecks are, rather than the vector DB side. But it might exist, which I'm definitely not sure about it, because no one would really be concerned about a bottleneck on the vector DB search side. So yeah, but we can still ask it.
Yeah, makes sense. Thank you.
Yeah, thank you. That's a good question. Thank you. Anyone, any questions anyone has? Performance.
Yes, I do. Hold on, please. Okay, educate me on this. This is from a non-technical person. How often does the performance metrics get done? Is this something that's ongoing in the whole process of training the LLMs, or is this at a set interval that performance metrics are performed? Thanks.
Sure. Yeah. So Mo, that's a great question that you're asking. So yeah, that's an ongoing process, because based on the question and based on the data that is coming in, it also depends on your data too, right? If you're just asking these questions on, maybe you have maybe 1,000-page PDF, or maybe this data is coming really real time. Maybe you're asking questions about a game that happened yesterday, or it's going on for days and days. So now the performance might go down, the retrieval performance might go down, depending on how the search is happening. So always, these are the metrics that you should always keep in mind. So these metrics should always be observed real time to check how well is your RAG process working. As I said, it all depends on your data set. If it is refreshing, maybe a data refresh, now there's a new set of documents that you have. Again, you need to go ahead and see how is your recall affected? How is your precision now? Any RAG that you create, the recall and precision would also imply how well is your data organized. Because if your data is not organized well, maybe you have 100 or 1,000 PDF files, and each file has its unique name. Maybe they're just named by some numbers or some different names. Maybe there's no proper indexing that's there within those PDF files. Then your recall would be affected. So this pre-processing is important, and also these metrics you should always keep on checking, because there's only subset of questions that you could use to check recall, right? Maybe you are building a RAG for imagine a mental health counselor RAG, a co-pilot, where you are asking your questions. Maybe you have anxiety or depression. It has to go into maybe I forgot the name of that, DS 140, or maybe a huge manual for mental health. It has to go into that and check for depression. Those depression might be only covered in certain pages. So you could get a lot of questions. Given a huge mental health manual, there could be millions of questions that someone could ask. So unless you did, RAG or did an evaluation for all those questions, there you can come and say, out of all those questions, my system is able to do like 90%. But it's very difficult for us to prepare millions of questions, right? So you usually have some subset of questions. You evaluate and you tell to the stakeholders, hey, my system is probably 90% accurate. And now you keep on getting new questions. And for every new question, you again go back and check what is the recall, what is the precision, how well you are able to get the right context, and what is the K value for it. You tweak the K value, means how many retrievals that you're doing. So it's an ongoing process, because AI is very undeterministic. They're probabilistic machines. So these evals or these metrics should always be continuously done. And that makes a product really different than a regular and many claim to say, oh, mine is an AI product, this is what we do. But no one would, if you go and ask them the metrics, they would probably not. I mean, I'm not telling everyone. There are a lot of enterprises who do evals, but the seriousness of that is I don't think it's really considered. I mean, it's not like an application where you build an application, you say, it's sitting in the prod, and now I'm just going ahead and just releasing a new version of application. It's not that easy, right? This is something that you should keep on testing. You always keep your instruments and check, hey, out of yesterday probably 1,000 questions asked, and what is my recall and precision? Is all the questions that are asked we're able to get the right answer, or someone is asking for a policy but my LLM gave him a wrong answer? They're asking about data policy, but the LLM retrieved maybe a policy for insurance, right? So those are the things that you should always like keep on going. So yeah, that's a great question. I mean, I don't know what's your background, Mo. Hopefully I'm talking with Mo, right? Is it Mo?
Yes.
I'm talking to Mo. So yeah, what is your background? If I'm just curious.
Process improvement, quality management.
Quality management. Okay, yeah. So I mean, definitely, quality management for this RAG is a continuous effort. It's an ongoing process, and that's the reason why many give a lot of emphasis on evals. They say, oh, evaluations, continuous monitoring of this metric should always keep going on to have a better AI product, which is a grounded AI product. Hopefully that answers your question more.
Thank you.
Thanks a lot.
Hello, hi Raj. This is Divya. So I have a question
Hey,
regarding
Divya.
the agent. How does that works with RAG, like in coordination with this, as well as the multimodal that you explained?
I'm sorry, I might have missed your initial
The
question. What was that?
AI agent nowadays are
Okay.
being created. So how does
Yes.
that works in coordination with RAG and
Okay.
in multimodal framework?
I mean, yeah, it works. There's a lot of see any any agent that is working in a long horizon task, like long horizon task is maybe you have your agent, you're talking with it, you're chatting with it, maybe you um, in order for it to go back in the history and to look for maybe you might have chat about maybe your personal information, maybe you created a travel AI agent. It should go back in history and look for what does Divya likes, like easy vegetarian, how does he travel, what the destination he travels. These are all some important knowledge or memory that the AI agent would need. So RAG really makes a good AI agent's memory. So because all of this would again be stored in the vector DB. All of your conversations, including the input and the output, will all be stored in the vector DB. And now you have a memory layer, which is basically asking a question, what should I remember? Right? That question is again going back into the vector DB and just checking for relevant data. So what should I remember? What are the important information? Maybe something your personal preferences are important, so it should also know what is important in all the previous conversations. So that's where RAG is important. And in the multimodal context, if your model itself is multimodal, maybe you're just like ChatGPT, you're probably sending it pictures on images to ask some questions. Maybe in the travel AI bot, you're using it to just maybe take pictures of your passport, or maybe you're storing your previous boarding pass information. So that's again is multimodal data that it might store, right? You can even ask questions about it, or your model would probably answer that. So maybe if that is all in RAG, you can have a conversation with that and retrieve data that is important. And now you use LLM's knowledge to to answer that. So this is where RAG is important. So AI agents, RAG is, many say, okay, AI agents, they build a travel AI agent. That's great. But if the AI agent should truly be something that is working over many years, then all it needs is a better memory layer. And the memory layer is simple RAG, is what I believe. Because that's a fundamental thing, right? It's just you need to store them into a vector DB in order to know exactly what it has to store, what is important. Hopefully
So
that answers your question.
yeah, so I
Yeah,
have secondary question I am being asked
sure,
also from other
sure.
people
Yeah.
is if I'm storing those data like personalized preferences, and so how does that saves it from from LLM? Like, does LLM have access to those data, or LLMs are being also retrained based on the preferences? and how my
No.
database is different than LLM um, runtime query. Like LLM also can remember, right?
Yeah,
If whatever
yes.
data I have.
So here we are not memorizing an LLM here, right? We are not retraining an LLM. All we are doing is adding the data back into, maybe you chatted with an LLM, you're just saying, I'm a vegetarian. Now, LLM, you gave that information to LLM, and LLM gave you an output. It gave you maybe an output to do a booking. It booked the flight for you, and that information, when an LLM or AI agent, right, that went in and did some work for you, maybe it went and booked flight tickets for you, and now it stores that information in VectorDB. So VectorDB is its memory, it's its brain, but it stores all of these different attributes, all of the previous chats. So that itself will define, the brain for your AI agent. So you need a vector DB that stores all of this information. So LLM doesn't store anything. I mean, LLM is more stateless, right? Because LLMs have a certain context window. So when you're trying to ask any follow-up question, this context window or this context lens should include data that is important. Maybe next time you go and say, hey, can you go and book a flight to Delhi? It should probably understand that you are vegetarian, you need a vegetarian meal in the flight, and you live in Bengaluru or someplace. So probably should go ahead and do to and fro from Delhi to Bengaluru because it already knows that that's what you. I mean, the simple experiment is now you go into ChatGPT and ask, hey, can you tell me what you know about me? ChatGPT will give you all the information, what it knows about you, because it does store your memory. It stores everything in its vector DB somewhere. It's not the ChatGPT, it's not the LLM that doesn't store your data.
So the main point is like, let us say someone is like not a technical person, and that
Yes.
person is concerned about their like day-to-day data. They don't want to. So how to explain them like your data is not being accessed by LLM or stored somewhere? Is there any like firewall or something that stops it? Or like we can make sure like, okay, this is not happening. Like
So
LLM is.
if someone is really worried about, I mean, first thing is all of these cloud providers or even big LLMs like ChatGPT providers, they say, I mean, they are, at the end of the day, they are storing your data, right? They not just data, but they're actually storing everything about you, like personal information and all of that. Because now if I go into ChatGPT and say, tell me about me, it will tell me everything. Like it does also tell I have a baby, what age of my baby is, it does know everything. So if someone don't want to have a cloud provider store the data, the best approach is you would have the data. First thing is you would probably create your own RAG process. Maybe you have your own vector DB, and you would also host an LLM, maybe a small language model or some LLM that you want to use. Or maybe if you want to use OpenAI, you could use OpenAI API, because OpenAI API is stateless. It will not store. They claim that, I don't know if they do or not do, but yeah, OpenAI API, and now you use your own vector DB, and vector DB could probably be, something that you host on the customer side in their firewall. And every interaction, like most of the AI agents are built in a similar way. So you use an OpenAI API thing, and now you API, and then you create this AI agent with that wrapper around OpenAI API, and then you store all of this data into a vector DB, and the vector DB is owned by your client. So that's one of the ways in which you can make sure that the client data is not going anywhere. It's all in the vector DB that's hosted by you. But if they're using anything like ChatGPT or any of those, they do store all of this on their end. Hopefully, I answered that question. Yeah.
Yeah, great. Thanks, Raj.
Yeah.
And one more question is, can I like if I need to experiment this in my local system, so how to start with this? How can I build my RAG and evaluation, like the eval? How can I build my eval so that I can test my own?
Yes. So evals is a bit tricky. In order to build this, I mean, for evals, there are tools to do evals. You should probably, before doing evals, you should probably create your data sets, right? What data set is it? So what is your use case? First thing, you should narrow down what my AI agent is doing. So first thing, understand that if you know exactly what your AI agent should do, is it acting like a chatbot? So if it is acting like a chatbot, what questions that the user would ask? Maybe you're building a resume creator chatbot, or maybe a travel AI agent. It could be a co-pilot for maybe a doctor who is just maybe he's just taking care of like just cancers and all. So they all have their own data set, and they all have their own set of questions that they would ask, right? When you want to do evals, okay, now you created your AI agent, which is just a wrapper around your LLM, around any of these LLMs. It could be closed source or open source. And now you create 100 or 200 data sets. I mean, 200 or 300. It all depends on how well you want to run your evals on. You create these data sets. And what are these data sets? These data sets are question and answer. And this answer is the ground truth. So you know exactly this is what the answer should be. So you have a question and you have the answer. You create this question and answer page, maybe 10, maybe 100 of those or 200 of those, and you run them to your model. So evals, so when you're doing 100 and 200 means you're burning through tokens as well, right? So when you're burning through tokens means your evals do cost money. So just make sure, just be aware that evals are not, evals are really great. You need evals to make your product really good, but this data set is something that you need to maintain and tag them properly, and then you get the output from those evals that you can manually go through and check if my RAG performed really good, because now it has to go ahead and to answer that question, probably it has to get that question from your data sets or maybe some sources. It could be any data source. It could either be from internet. It could also be a data source within your own environment. And now you have the ground truth. You're just checking out of 100 or 200 questions, how many questions it answered right. Did it answer 90% right, or it only answered 80% right? How would you know that? Because you already have the ground truth for it, right? That way you compare the input and output and compare it against your ground truth and see if your LLM is doing good or bad. And then if it is doing bad, now you go back and add a read anchor, or go back and create your prompt properly, or make sure that your data that you're storing in your data source is properly aligned, or change your algorithms to check if that if it requires any kind of pre-processing. Maybe you create a graph RAG, or maybe create a graph with that data set so that you're very certain that the data that is going into your LLM or the context that you're sending to an LLM is properly aligned. So there are a lot of optimization steps which are available. There are also tools that are available. There's a tool called LangFuse that you can use to do that. So let me show you that. We had a session on LangFuse previously. So if you ever want to get into that, you can always, I mean, we did that session long back. So this is a LangFuse dashboard where you could actually check for different metrics that you want to go ahead and look for. So look at this as a process question. So here I'm just asking who's the US president, latest president, and it is going ahead and getting all the information from internet because it has access to internet. So it got this source. So it is using this to answer it. So I know this is the right answer. So you create these data sets here, and then you create a continuous improvement pipeline that can keep on improving your new output. So it's not a one-time thing, because now once you're live, you get new data and you again do it. So you might ask, okay, how who would be checking those answers? It would be humans could do it. Like if it's a domain expert, maybe a doctor who can review and say it is a good answer or a bad answer. Only domain experts could do. If you're building an AI agent for maybe any domain, maybe you're creating a AI agent for civil engineering scheduling or RFPs, it's a different domain, which I mean, I may not be aware of it, but the answers that are generated would only be evaluated by someone who already knows that domain. So they should able to answer that. And if you feel like you need to scale that judgment, you can always use LLM as judge. So LLM as judge is something that you could use to evaluate the answers. So where you're using again a different LLM to judge the answers and make the system better. So basically, to make your AI product better, you're again using more AI. So that's how you make this evals and everything run. So we will have a session on evals. Probably I'll plan it for next month. But yeah, I think it would be a great thing that you can always implement and use. As far as implementing a multimodal RAG, I'm going to share this I'm going to share the repository now that you can use to start working on this multimodal RAG. I don't know if you already have a Ollama locally or not, but I have a repository that I'll share with you guys, and you can all go ahead with this implementation. I think we have 1 hour, so who all have at least you could set up your environment and start working on this. I'm sharing this repository.
Sure, I do have Ollama, so I can try.
Yes, so let me share that here. So within Ollama, it's better to use a smaller model, a smaller language model. So I don't know what machine is yours, but you could also use OpenAI API if in case you don't have an Ollama locally, or your Ollama is taking a lot of memory. You could always use an API. So this code will cover both use cases. Yes, Avinash, this is recorded. We have a YouTube session, like we have stream for YouTube and all of those. So you can always look for that. Okay. So you can look for that. So Divya,
Sure.
I have shared this. Yeah, you can review this code.
Sure, thank you. And actually, I have CPU. I do not have GPU in my system, so that's why I think Ollama, as you mentioned, will
Okay.
be quite slow.
Okay, if you don't want to do that, all you can do is just come into .env here. You can also include OpenAI API that you can create an OpenAI key, and also use a OpenAI model that you want to use here. So you could just comment out this Ollama and just replace that with OpenAI. And hopefully, did you ever created OpenAI APIs previously?
Yes.
Okay, then just go ahead and use this, and then I think it should be good enough.
Okay, sure. Thank you.
Okay. And you could also use any data set. As of now, I'm using some manual here to work on it.
Yeah, that would be helpful if you can reference some data set I can experiment with.
Yes. Yes. So if you see the data here, I have included few PDFs. These are the 2 PDFs. This is one of the PDF that I don't know if it will be rendered. Yeah, this is rendering. It's basically something to do with the Zebra scanners, the product scanners. The reason why I took this data set is because, it has mix of both. It has text and also a lot of images. And it also has tables as well. If you see if you look at this, it also got some tables. So I felt like this would be a good use case for us to work with multimodal RAG. For anyone who wants to just get this up and running, go to the README file. All you have to do is to first you clone the code. You can use Python. If you have Ollama locally and you have a GPU or using MacBook, I think this should be a fairly simple exercise that you can work on. All you have to do is to create this virtual environment locally, and then you install your dependencies, and then you pull a local vision model. For me, I'm using Qwen model, but you could also use Llama 3.2 vision. If anyone needs on how anyone's need help on installing Ollama locally, please let me know. If you think that you have a MacBook that you feel like you have good resources, then I'll share you the steps on how to install Ollama. It should be fairly simple. So, okay, that's a quick question. So minimum RAM for Ollama, it all depends on the model that you're trying to pull risk. So you could look for the RAM what model, because Ollama for Llama Vision, let us legend what RAM is needed for Llama Vision on. Let's ask that question. Adam, so you're saying you have this Intel Arc 140 vGPU. which I'm not sure. Okay, Samsung Galaxy Book Pro, 32 GB RAM. I think you should be able to run, Adam. Did you ever install Olama previously? Can you, I'm sharing this thing. Can you install Olama for your Windows machine? Yeah, I'm sharing this to you right now. Go ahead and start installing Olama locally. And so I got three questions before. I just want to cover them. So first question is, I think previously asked a question if VectorDB would have caching. Yeah, and Agent Word says, yeah, it does have VectorDB, does support caching mechanism to enhance performance for repeated or similar queries. So that's good to know. I mean, I was not aware of that before. But this can include both traditional key-based caching and semantic caching. So semantic caching is something that probably we would need. The results are stored and fetched based on vector similarity rather than exact matches. Yeah, okay, yeah, I think it is available. I mean, I now recollect my memory. We have done something similar on Snowflake side before. So yeah, there is something called semantic caching, which which does the same thing. Basically, we did the implementation for some SQL NLP to SQL conversion. So yeah, you could probably do that. So Karthik, you're asking me what are the typical key value used in metrics. So it all depends on the data that you have, and you should basically experiment with it. You could start with 10, or 10 is ideal because depending on how big, how many chunks, like because when you're trying to create this data, pre-process this data, it comes with a lot of chunks. So you should probably know exactly how big is your each chunk, and then based on that, you can change or update this key value. So you can just start with 10 and slowly iterate. And end of the day, this decision again depends on your data. How big is your data set, on what you are trying to implement this RAG process on. Based on that, you can have your KA defined, and also what LLM that you're using. Because if in case you're using a small VLM or LLMs that doesn't have a lot of context length, so you're basically burning through a lot of context, or even a lot of tokens too, right? If you could also do K30, right? When you do K30, maybe not of 30 results, you would get your right answer somewhere, but still it's a lot of noise, so your LLM would probably hallucinate with a lot of context. So you should do a lot of iterations, and you should also run a lot of evals. So you could probably run an eval for different key values and decide the best one for good metric. So you probably need to run those evals by yourself. Yes, context is everything. That's the reason why context engineering is something that everyone is talking about now. So yeah, context is something that's really important.
Hi, I have a question regarding how I can install the Olama model. I'm just going through the README file, and I set my virtual environment, and I'm not sure like how I can run the first command, right, which is pip install getting that requirements.txt, because it's in a Git repo. How can I clone from an open source repo? Do I need any keys or something, or I can just clone?
You could do a Git clone. You could do a
Okay.
Git clone from that. So I don't know. Are you using any IDE? Like, are you using any VS Code or
Um,
something? No?
no, I'm not using. I'm actually using Mac, and I'm running that through the terminal.
Okay, okay. So in the terminal, you could run a command called, do you have Git installed on your Mac?
I don't think so. I think I don't have it. It is
Okay. I mean, yeah, I think you should probably set up your machine. So please
okay.
do install Git. So you could ask AgentBot some steps on how to
Okay.
do that. But if AgentBot gives you any not better answer, just let me know. I'll help you out with it. Um, yes, Adam. I think Olama does the optimized for CUDA engines, but you could always use Docker to run these models. So you could run something called, if you have Docker in your local machine, you can use Docker. I mean, even then, yeah, you should probably have this. You would probably, if you have GPU, then yeah, it would be NVIDIA GPU. I think it will probably be better. So yours is not NVIDIA, it's just an Intel Arc. Okay, it's a different Intel GPU. Yeah, that's a problem. Most of these tools are everything is optimized for NVIDIA. Okay, okay. So Sri, if do you, hopefully Agent Bot would give you that answer, like how to install Git. If not, I'm sharing you this Git install on Mac so that you can
Right.
go ahead and start using this Git for Mac. You could install that through Brew. So just go ahead
Yeah.
and do that.
Yeah, sure. Thank you. Let me try that.
So what is your background, Sri? Like, are
Um,
you
so my background is I'm working as a cloud data engineer from almost like 10 plus years. Yeah,
okay?
mainly, yeah, I'm from a traditional ETL data warehousing background. uh,
Okay,
Back in like maybe 10 years ago, and then started with big data, Spark, and then got into Amazon cloud services, and then have a little bit of experience on Azure services as well. Slowly
okay,
getting into this AI space. I'm not
okay,
practically I'm not using at work, but
okay.
I just have exposure to one of the use cases where you know we built a chatbot using a Snowflake feature called Cortex Analytics,
Yes,
right?
yes,
So
yeah,
where, yeah, we had to, write some AML files with all the like known queries, right? On top of the enterprise data that we have. It's just that you have to write a question, a SQL question basically, and then provide the SQL query, and then build that AML, and then provide it to
yes,
your
yes,
maybe RAG or like chatbot.
yes,
Then you ask
yes,
questions, and then it will answer or like fetch the answer from Snowflake data that you have, right? So, but
yes, yes.
yeah, but yeah, I'm relatively new to the space, and yeah, that's why I was asking the questions around the vector database, and then I'm trying to relate how all these steps are stitched when you walk through the RAG process,
Yes.
right? The ranker, retriever. Yeah, these are all new for me, so just trying to understand.
Oh, yeah, that's great. I mean, yeah, definitely. Since you're coming from a traditional background, I mean, what you're seeing now, what's going on. So when you create that YAML, right, that's basically you're creating semantic. You're basically telling your first thing is when you create that YAML file, you have the semantic model of how your database is, how your data warehouse is, how exactly are the different schemas, all of that information
Yeah.
that you give to the cortex, and now you ask questions. So it's basically converting NLP to SQL, and your SQL that is generated is grounded in that YAML. So whatever your YAML that is generated, so you're basically retrieving that YAML from your Snowflake cortex, right? So
Yes.
cortex is basically creating that semantic layer, and you're exporting that into YAML. So any SQL that it generates later on, it's all grounded with that information. So it's not just generating on the fly, rather it is just understanding how your tables are created, and now it generates your SQL, and it just purely answers that question. So that is what Cortex
Yeah.
is. If you go under the hood, Cortex is doing the same thing.
Okay.
It's just a layer. They just say, okay, Snowpark. What is Snowpark? It's just nothing but an MLOps platform. They already have open source, closed source platforms. So they just market in a different way. So they say vector search. They don't say vector DB, but they say Snowflake vector search. Even that is abstracted now. So that you will probably not even see. Like you say, okay, I just go upload this and it will get you an answer. So we worked with a lot of Snowflake before. So we did do a lot of work with Snowflake previously, way before Cortex came out, because Cortex
Okay.
was kind of slow in giving us the RAG process. But even then, right, it also depends on is it accurate answer or wrong answer? That's something that it's only up to 95%, right? It's not 100%. So when
Yeah.
you ask a question, you can't always say, oh, it's 100% right. Sometimes it will hallucinate and will give you wrong answers too. But end of the day, a domain expert like you should always review the SQL that was generated and then validate it.
Yes, that's what happened actually when we initially
Yes,
built the chatbot, right, on top of
yes,
our data. Then
yes,
you ask like a question about give me more details about a person, right?
yes.
So in the first go, it is giving an answer. Maybe let's say it is the right answer. And then again, after a few minutes, if you query, there is no guarantee that it is going to respond with the same question, right? So that's what it was happening. We had to work with closely with the Snowflake guys, and then then like they had to do something, and then it was a tedious process. So
Yes, yes, I understand that. So because the problem is, right, if you go with a vendor, they usually they usually control a lot of stuff, right? There's a lot of friction. But still, it's good to start because now you don't have to deal with a lot of vector sets and all things are done on their end, but the LLM would probably be something different. So if you see here, there's something called evals. So it's the same thing that is going on in your case as well. So whenever you want to create or your cortex, you want to see how accurate it is giving the answers. Like just now you said, okay, we asked about some person. So it might not be the only question that you would ask, right? There could be hundreds of questions. So you would have to create a data set and run those data sets within your Snowflake to check how it is processing it, what SQL it created, and all of it. So you could go through this observability course to understand how you create your evals and how well you can implement this. And by the way, we are actually creating a tutorial on this. It's October 7th. Now, sometime in November, we'll have a Cortex, Snowflake Cortex demo or event in which we'll go through all of this as well.
I think that's going to be great session, and thanks. And I'm able to gain some knowledge from this session, and then the slides that you shared and the way you explained, it's all like making sense. And especially for someone like who is new to this space, right? Like me, I'm able to relate the stuff and then understand. Thanks for doing this.
No problem. Yeah, I mean that's definitely the whole purpose of this, because someone who's already coming from a traditional background, in order for them to switch or just change the gates and get into AI, I think that's what Agentversity we want to enable everyone to get into AI. But it's not a huge thing to learn, but still, it's a thing that is very tricky, right? When you're coming from a traditional background where where you rotate a DAG and the DAG never changes. But imagine in some LLM solution that you build now in Cortex, but everyone says, okay, now I'm a business user, I just ask NLP, I get the right answer every time. No, maybe the quality of that end of the day depends on you as an AI engineer, or maybe a Snowflake data warehouse engineer who's working on Cortex, how to run evals and all. So it's a shift in mindset, but it should be straightforward for you to digest it, because it's just that you should always understand these LLMs are probabilistic machines. They always make mistakes. If someone says, okay, I have Cortex now, I have Cortex Analyst. There's also Cortex, there's also a tool called Analyst. If I have Cortex Analyst, I would not need any kind of DBAs. And I say good luck with that, because someone says that, I mean, because there's a huge gap, there's a huge problem. These models are really not that great in answering every question possible, but at least you could make this text to SQL to be great, or you don't have to run the same queries every day, right? Your fatigue in terms of running the same query every day would probably be reduced with this, because now you give it to the business owner who will probably ask a question, and you give your final approval saying it's right or wrong, because now you went through previous generated SQLs and you know exactly that's right or wrong. That way, with augmented with you, I think the quality of life and even the productivity is what that's boosted with this approach. So I think, great going. If you have any questions, let us know. And also stay tuned for our next session on Snowflake. We'll probably publish that in the next couple of days.
And Raj, can you hear me?
Yes, sir.
Okay. Just for some context, my background's in traditional data analysis and data management and stuff. I'm also certified Safe 6 POPM, Safe or PSPO2, some product owner, product manager as well, but I've got the technical expertise as well. I am not a DBA,
yes.
But I know, I know what to look for and how to talk to them. My aspects on LLMs are within the bias, the ethics, the governance, the AI governance spaces, and the training data is the training data. effective,
Mhm.
whether it be synthetic or internally compiled.
Okay.
So I am not a programmer. I can read and understand most code and
Mhm.
get what it's doing, and I can effectively communicate with programmers and stuff,
Mhm.
but I do not write any kind of code. I don't consider a SQL to be code.
Okay. Yeah, yeah, that's
That's
nice.
an easy way. I've been doing SQL for over 25 years, so that's
Awesome.
second
Yeah,
nature. But I don't
awesome.
consider that coding.
Yep.
So I approach these more from the product manager, product owner, and the
Mhm.
governance standpoint, and also
Yes.
the ethical use. Because
Yes.
lately, especially with agentic AI,
Yes.
not so much
Yes.
RAG. RAG is going to get your fine tuning, so to speak,
Mhm. Yes.
out of the model. I've seen a lot of unethical usage of agentic AI lately,
Yes.
what I
Yes.
consider to be unethical anyway. I know people that will do it on a daily basis, claim
Yes.
AI generated material is their own. In fact, I
Yes.
don't know if you heard about it, but Deloitte just got
Yeah.
just pay back the Australian government 400,000 for
Yeah.
something they produced that was totally AI created, and there were errors in it, and that's how
Yes.
they they knew it. But one thing
Yeah.
with code, one thing I see with code a lot is people relying on AI systems to write code for them. And I always
Yes.
say you cannot use any AI system to do something that you cannot validate yourself.
Yes.
Otherwise, you have no idea whether it's good or bad. It might work, okay,
Yes.
but it may not be secure. It may not be efficient, etc. And
Absolutely.
that goes for any aspect, even something I tell product owners that if you don't know how to write a good story or a good epic and
Mhm.
good acceptance criteria, AI is
Yes.
not going to help you do that. It's not going to replace skills
Absolutely.
you don't already have.
Absolutely. I think, yeah, I definitely agree with all you said, Adam. I mean, without domain expertise, I don't think you could probably go and validate what AI did. AI is just for anyone to have a boilerplate to start off with rather than going through everything from scratch. But for someone who can just claim and say, okay, and I want to be a vibe coder overnight, I think good luck with that. I don't think there's any way they can validate the code, best practices, code coverage, what libraries it is installing, where it is getting the libraries from, is like how are you hard coding your SQL injection code? I mean,
Yeah.
someone even say, hey, all vibe coders I created this software, just go access it, and they just put HTTP localhost. And the people clicking and saying, oh, I can't open it because they're not aware that, localhost is something that only works locally. So yeah, definitely, there are a lot of vibe coders who even created software, which got hacked really fast. But I see eventually like more and more this AI generated code, especially like I use a lot of AI generated code, but end of the day, I evaluate, I see what it is doing, I check for every detail. And but if you even if my interns are trying to use this AI generated code, I did see this a lot. They're burning through tokens,
Yeah.
a lot of tokens. I'm like,
Oh,
why are you
I
burning
talk
through a lot of
about that
tokens?
as well. I know people that have taught classes on agentic,
Yeah.
and they're
Okay.
using verbal prompts, and they're using
Okay.
all these extra words, and I'm like, you don't need pleasantries to do a
Hmm.
prompt. Uh,
Yes.
the AI system doesn't care if you're nice to it. If you say, hi,
Yes.
how are you doing? It doesn't care.
Yeah.
You
Yeah.
just use words equal tokens.
Absolutely.
Tokens equal money. All right.
Yes. Absolutely.
And
Yeah.
yeah, there's just a lot of work that's done using AI systems that people are passing off as their own
Yes.
creations. You'll see a lot of it on LinkedIn. I've been able to spot it. I took a
Yes.
course that I actually got kicked out of. I got kicked out of the
Oh,
webinar
okay.
because he was teaching how to create posts to create viral posts, how to write a prompt to
Post.
create viral posts.
Okay.
And then to create the post, to create an image of themselves as if they were recording themselves in their voice, and then post it automatically at the most opportune time for the algorithm. And I said, those are fake. And I was calling them out as fake for doing that. Now, the workflow is absolutely legitimate, right? It's a valid workflow use case. It's the usage of it to have AI create something, post it as you, and purport it to be you. I said, that is unethical. That's wrong. And he went so far as to say, oh, you can even extend this and have it monitor your contacts. So when they post something, it automatically generates a post as you, a comment as you.
Yes.
And I said, that is as inauthentic as I can think. To me, everything with AI has to be transparent. Transparency is key. And I'll see a lot of videos that are done with AI, but they'll put on there, this was generated with AI, right?
Yes.
AI being used as a tool. Nobody wants to spend 10 or 15 hours doing a fancy infographic when you can put all your ideas in and have a system generate the infographic for you. That is productivity. That's another tool to be used.
Yes, absolutely. I mean, I use a lot of AI. I mean, today in the presentation too, you might have seen some infographics which are generated by AI. But at least for visualization, instead of me spending hours to show that, I just went into Gemini and asked it. But I usually prompt it and tell it, hey, this is what I want to showcase, and it does create it. But yeah, I do agree with you. Yeah, but at least you need to do that, because otherwise, I know someone posting about MCPs, which is completely different than actual meaning of MCPs, because they don't know what an MCP is, and they post it on LinkedIn with 20, 30 likes and so many shares. I'm like, come on, like my so that's a problem, right? Yeah, that's where you're also spreading misinformation. So that's definitely AI ethics governance is definitely needed. I do agree with you, Adam, on those. But thanks for sharing all this information with us. Yep. And so Karthik just says, okay, I have to drop. Rajulal from this presentation will be available later. Yes, Karthik, I will share all this, including the LinkedIn, the slides and all, will be available on there. And also we have GitHub that I've pushed, which by the way, is actually AI generated most of the code, but still it works. It doesn't have any kind of libraries which are any it does have good libraries which are widely used, and also please feel free to use that code. Yeah, I mean, let me go ahead and just showcase the RAG process, how it works. Let me share the screen to do that. So once you install your RAG, there are different ways. Like if you have Ollama, as of now, I'm using Ollama Qwen model. In the documentation, I have included Llama 2.5, but I'm basically Llama 3 version. But here I'm using Qwen model, Qwen 2.5 VL, which is 3 billion parameter model, and just running, and just running with with Ollama, so running with Ollama. So there's a few commands that you need to follow to do that, to host it, to serve it, and then use it. I've documented the process. All you have to do is change or update this env file, .env file, and include your variables. So since I'm using Qwen, I've just put Qwen as my model. But if you're using OpenAI API, but if any of you doesn't have GPU, just go with OpenAI compatible config. So all you do is just uncomment this and then go with the OpenAI API key and the model that you want to use. So you can create OpenAI API key from OpenAI API platform. So this is the URL endpoint that you can use to create the Open API. So for this, you probably need to put some maybe some credits or maybe your credit card, and go ahead and just use that. And it is configurable for both ways. So that's what .env has. It has a local provider and also a OpenAI API provider. As of now, we can go through the code base. There are a bunch of them. We are using an algorithm, the hierarchical small worlds algorithm, which is basically including all of your PDF files as the content within a PDF in a graph, and creating an embedding layer. It's actually creating a graph with it. We have already covered that. And I think I've also shared the PDF that we're using previously. So yeah, this is the PDF file. And if you want to use Ollama, just use the Ollama pull, and this is where you have your data. Once you install it, you could try with the Python CLI commands, or you could also just run Streamlit. You have to install Streamlit, and once you have Streamlit installed, you can just go ahead with this. Run. You could just go ahead and run this model locally. And within this, there are just a moment, let me share the screen that. Yeah. So you have the pipeline file. This pipeline.py. This doesn't have all of your details. It does have all of your important information that is needed to run the RAG. So this is where you're creating the different data models that needs to be created. The first thing is the answer process. There's an ingest. Ingest is where you are ingesting the data set and creating chunks of that data set. So that's what this specific class implies. Because most of the data that you create or embeddings for, they are created by chunking the data, because you can't, if you are creating it for all of these PDF files, you probably need to do that in a based on few chunks, like not like whole document, because that will not capture a lot of information. And by chunking, you're basically reducing the data set size. And then you have this answer, which will answer a lot of your questions. And we are using a retriever from here that's basically interacting with your vector DB to scan to capture all the text or image chunks that are relevant to it. So it's collecting all by different path types. And if you can go through this code, you would see it's capturing different chunks that are really very similar in the vector DB. They are by using KNN. And you could also check if you're using HNSW index, which is the algorithm that is storing the data within the vector DB. And you also have multimodal embedder. And the multimodal embedder is what you are using to create the embeddings for. We are not using a vector DB here, but you're just using a library called HNSW lib that will be used to that's basically doing the same thing as vector DB, but it's very lightweight, because if you're running it locally, you don't have to create all of the vector DB. And then within the settings.py, this is where all of your configuration for how to get this model, how to switch between different providers. As I said, you could actually use local Ollama provider or even OpenAI provider. So the settings control that. This controls the configuration for your code, and And right here, you have the, all of the specific information that is related to your LLM providers, like what configuration. If in case you're using locally, it's an endpoint where your OLAMA is running, and if it is OLAMA provider, then this is a different workflow to generate. And if you're using OpenAI Vision or the OpenAI API, this is a different workflow for you to generate the output. Yeah, I think overall, from high level, this is what we're doing. After the, let me just go ahead and run this code that I can. So we're on the code. Where you can see the screen. In the GitHub, the article that I have uploaded was around the PDF that I uploaded is for this product catalog. And if I want to ask a question, probably maybe I want to ask about like something like power up. So how do I know if the device power up or device powers up? So let's try to ask that question and see. Before that, we have to create the embeddings, right? So for that, you need to create this build or build or rebuild index. It's able to do that. It's actually building the embeddings for it. So all of this data that we have here, it's trying to chunk that and store that in the vector DB as numbers and vectors. Now, the question that we want to ask is, can you detect the and just I'm running the rack. So as of now, it's just going ahead and retrieving that information from it's actually checking. Okay, so the power up is indicated with short, high beep is what it says. And if I go back here in the documentation, it does say it's high beep. But it is missing out on low and medium because probably I would need low and medium. I would come up and ask the same question again. You would also see how undeterministic the system would actually behave. I don't know if it's caching or just created the same one. Let's see. I think it just still says just retrieving and generating. So as of now, it's using the Qwen model locally. So it takes a while to run the Qwen model in the local machine using OLAMA. Or we could ask transmission error, how to detect transmission error. So this is not a perfect RAG because it's not optimized, just done for the to basically showcase how it works, multimodal RAG works, and also different components that go into this multimodal RAG. Still waiting for this. And you could also ask questions by uploading an image. So if there is a specific part that you want to get the image output for, or maybe you have a question around a specific part of your documentation, you can upload an image and ask a question like, what is it? D8, okay. It's taking quite a lot of time. I should probably change my key value. Maybe it's taking a lot of chunks and going ahead and answering that. But yeah, let's wait for some time and see whether it will retrieve that answer. If it was the GPT model or GPT-4o mini, it would probably be really faster than this, because as of now we are running all of the embeddings and everything on our end. So because since we are using Llama, it is taking a while to answer that. I don't know why is it taking even more time, because I do see here the request went into the model. The model also gave an output. Or I just want to check if my, okay. Oh, there you go. So if you see this, so it just gave the answer like how to detect the transmission error. So it has given a lot of information regarding the barcode. Okay, look at this. So this is one of the biggest mistakes I think is in my output. I did not put guardrails on how big my output should be. So the model just went in and just spit out all of this output, which is almost 120, 133 lines, and probably might have lost this context length. And then it stopped there. But if you see, the model kept going because there was no guardrails for me to put and say, hey, I haven't put any guardrails to say this is how much output that I can only spit out, not more than that. You could still control that from the model side. But as of now, since that is not done, when I say how to detect the transmission error, it is just going out there and just spitting out a lot of information which is related to the same thing. Or it might also getting information from its own mind. But still, you see the RAG process is not behaving that great. We probably need to fine tune it, maybe add a re-ranker or even add more context to my PDF file. Because the PDF file that you see here is not, it's just more of a, which has a lot of images. It doesn't even have a lot of information. Maybe some information is there, but not a lot. So if you see here, most of the information that you get is not grounded, because some information is from the model's own model weights, which probably something that not expected from here. Let's say zebra device. And let's run the RAG now. That explains why it just took forever to answer that question, because it just took 1 minute or 1.5 minutes to just come out and spit out so much data. Okay. So yeah, I just came out with a simple answer now. And there you go. It does look like something that we might expect from this device for the Zebra device, but still we don't know if that is a right answer or wrong answer, because it doesn't have citations, right? Is it referring to the same part of our data, or is it referring to our documentation here or not? That is something that we're not certain, 100% certain, whether it is retrieving from the right information or not. So at the end of the day, it's again up to us to refine this, fine tune this information, and also fine tune this process of retrieval, and make it more grounded. So that's what is missing. It's just missing the groundedness. And how to improve this? It's through robust evals and probably asking a lot of questions, and also asking some questions which are related to the model itself. So if I come here, I can also ask a question on maybe the image. So all I can do is Maybe I'll take this image. I got the screenshot. Let's go ahead and ask a question by uploading an image. What do you see? So let's see what output generates here. As of now, I've uploaded a screenshot where I just took out an image and asking questions on this. The accuracy or even the model output would probably be improved if in case you're trying to use some data which doesn't have a lot of complicated stuff like what we have here, because this has a lot of images. It also have a lot of barcodes. So illustrating the connection setup for barcodes with the diagram shows a barcode scanner connected to a computer via USB code. The scanner is shown being plugged into a USB port on the computer, which is connected to a power outlet. The diagram also includes a label indicating the barcode scanner model as M123 scan. So it's basically describing what it does see here. I mean, Qwen 2.5 is really great. It's a great model. But yeah, just telling a bit more about this itself. But even now, I say it's still not grounded, because if this was grounded, it should probably refer to the document
that's coming off from this image or from this document where it says this is what it is. Like maybe it is talking about how digital scan automatically detects the host interface type and uses default settings. So maybe some text related to this, because since we did this embeddings, so these are all related. So if it has to go out and fetch, it should probably fetch something related to this. If we had some chunks that are displayed here, maybe we could have just knew that whether that information is actually retrieved from the document or not. So that is there is a major thing that we probably need to look at. So in terms of RAG, groundedness is also one of the important metric that you should probably look at, because if the data is not grounded, then your output is not perfect. But at least it is able to tell you what it is. It just is that too based on its own knowledge that's baked into it. So yeah, I mean, you could all play around with this. If you have any questions, feel free to push or send a message on the meetup group. And I think we'll go through this. If you want to contribute to that repository, please feel free to add a little bit more code, or maybe you want to create your own RAG. You could probably do that. Going forward, we might go through some sessions on evals. So we'll run some evals and take it from there. I do see some comments. Okay, sure. What are some ways to make system more deterministic? So one way to make the system more deterministic is to create a first thing is to make the system more grounded. And if you make the system more grounded, then it is more deterministic, because now you know if it is only retrieving, talking about your documentation. You should able to make sure, you should tell the system never to go out or use its internal knowledge. Rather, you could always make sure that it has to refer to this documentation. And when you say more deterministic, it only defines proper evals, and also um, how much deterministic it has to be. Like, is it 95% deterministic or 98% deterministic? That's it. But it doesn't mean that it will be deterministic all the time. I mean, it's not 100%. Maybe you could push it to 95 plus, but it may not be 100%. So that these are ways in which you can use LLMs to do it. Should the embedding model be matching the embedding model of the VLM embeddings model of the? I mean, embedding model could be anything. Embedding model is just it is basically doing encode. It is basically encoding the data and it is just sending that information to your VLM. So you could use any any of these embedding models. It doesn't You don't have to use something that of the VLM itself. You could use other embedding, because embedding models are basically trying to compress and encode the data, um, all of your information into a high dimensional vector space. That's what they're doing. They're basically encoding that information. So end of the day, it's up to you which embedding model that you want to use, because you're just retrieving that information and sending that to an LLM. So VLM or LLM doesn't really tightly couple with what embedding model you're using, because embedding model is only trying to, and also what embedding model is also important. Like, are you trying to, because any input that you're sending it to an API or any of these models, they have their own embedding. If you're using for OpenAI, they use their own embedding models. And But if you're talking about embedding for your RAG process, where you're using encoders to create embeddings for your own data, then it could be any, because that's only acting on your retrieval part. Um, where do we find vector DB configs in the repo, and what kind of vector DB are we using here? So we are using something, we're not using a vector DB. We are using an algorithm that is powering a vector DB called HNSW library. We're basically using a library to do this similarity search. Not exactly a vector DB, but you could use a vector DB. You could use maybe Milverse, Quadrant, and all of it. Since we're running this locally, we wanted to be a bit lightweight, and we're using this library to do that. HNSW module, which I think I've showed previously here. You could see that here in this. Yeah, this is the library that we're using. It's the same algorithm that we have for to create a vector DBs and all. So it's based on C++, and what it does is fast approximate nearest neighbor. So it just retrieving that is nearby to the data, how different data sets are. Once you're creating embeddings in the high dimensional vector space, it's basically retrieving different similar or nearest neighbors within that high dimensional vector space. That way it is able to retrieve information that is nearby. But you could always use a vector DB here, maybe Quadrant, Milverse. There are a lot of vector DBs that you can use locally. Awesome. Thank you, Mo. So I think we're right on time. I mean, we almost have 7 more minutes. If you guys have any questions, you can discuss, or maybe anything that you want to share about the work that you're doing, you can share. You can definitely share now. Um,
We just wanted to know one more information, right? So when you uh, basically deploy all your code for RAG and then start asking questions, so it is going to respond you something, right? So in between asking a question and then getting the response, like how can we see the traces, like where it is exactly going, like step by step log? I think you were discussing about Langfuse or something. Is it the place we have to see the traces?
yes, you could check that with Langfuse. So, but you need to configure Langfuse.
Okay.
So Langfuse uses something called OpenTelemetry to do that. So Langfuse SDK is something that you could use. So if you want to, so the Langfuse SDK would allow you to use, to get those traces. Um, and All you do is you have a simple SDK. So first you should have Langfuse running locally. And then once you have it, you can just add a decorator to do that. And if you see here, you have, yeah, the different SDKs here. So it all depends on, I think it's a two SDK. They have a SDK 3 that actually helps you to do this here. So yeah, I can share you this documentation. You can just go ahead and if you want to add some observability to this code, you could still do that. But yeah, this is the documentation that is there to get the observability for all of this RAG process.
Okay, so can we use this repo and then contribute like maybe
Sure.
some things like this, right? Integrating lang views for
Sure.
tracing. Yeah, I'll maybe play with this repo and then try to
Absolutely. Yeah, that would be
again, like
helpful
it
because
might take a couple weeks or so because I'm a beginner, so yeah, it might
no
take some.
problem. Yeah, you can take your time. But yeah, no, I think it will help you to have this as a starting point and then add code to it. Yeah, feel free to do that and raise some PRs. We'll always review that and
Yeah,
and give
great.
some
Thank you.
feedback too. Yeah, thank you.
Yep, sure.
Okay, so if you all don't have any other questions or anyone has any other questions, we can talk or maybe we can end the call early on and maybe give you 5 minutes back or 4 minutes back.